So, hey everyone, welcome to our presentation. Myself Bhavya, and with me is my teammate Krish.
Hello everyone. We are excited to guide you through something interesting today. Our arithmetic operation simulator designed for computer operations and architecture.
Yeah, and instead of just explaining it like a normal boring presentation, we thought we'd walk you through the concept like a conversation. So let's begin.
So first talk about what the simulator actually is. The arithmetic operation simulator is basically a Python GUI tool which helps user perform arithmetic operations like addition, subtraction, multiplication, and division.
But the cool part is, it doesn't just work with normal decimal numbers, it works with binary, octal, decimal, and even hexadecimal numbers.
Exactly. So instead of you manually converting the value into different number system every time, the simulator does that automatically.
You just enter your number in one of the four bases, select the operation, and the result gets displayed in all the four bases.
Now let's talk about the main features. The first big feature is multi-base support. The simulator can detect what kind of number you type, whether it's binary, octal, decimal, or hexadecimal.
Second, it has built-in error handling. So, just in case you type something invalid or try to divide a number by zero, it gives proper error messages instead of crashing it out.
The third feature is that it has a very useful, friendly GUI. We built it using Python's GUI framework so that even someone without technical knowledge can operate it easily.
And lastly, the design is kept clean and consistent using a separate styling file, so everything looks visually unified and designed.
Okay, so logic module which handles base detection, conversion, arithmetic functions.
Then we have the GUI module, which deals with input fields, operation selection, and result display.
Lastly, we have styling module which unifies font, color, padding, layout, and other visual components.
This module breakdown ensures that if we want to start and update any part later, we don't have to touch the whole entire code.
At a high level, the GUI takes the user input and passes it to the base detection function.
Once the base is detected, the input is converted into decimal, so arithmetic becomes simpler.
After performing the calculation, the result is converted to all four number format again and returned to the GUI for display.
This step-by-step flow reduces complexity and avoids repetitive or recursive code.
Now, let's explain some core functions. Base detection function. This function checks whether the number entered fits binary pattern, that is zeros and ones, octal pattern, digits from 0 to 7, decimal patterns including 0 to 9, or hexadecimal pattern from 0 to 9 and E to F.
If none of these match, the simulator throws an error saying invalid input.
Next is the conversion routine. These converts number between all four systems.
And finally, the operation functions. This include add, subtract, multiply, and even divide. Each one checks for errors, especially division by zero, which will throw invalid input error or zero input error.
For the GUI, we use entry fields for input, radio buttons, or drop downs for selecting operations and result display frame.
All colors, fonts, and spacing are defined in a separate styles.py file, so the application looks neat and uniform.
The simulator handles empty files, invalid base inputs, invalid characters, and even division by zero.
Instead of crashing out, It shows a clean message like please enter valid input or error division by 0.
So to sum up, the arithmetic user perform arithmetic operations like addition. Operation simulator handles multiple number systems, convert between formats automatically. It is user friendly and is well structured in modular code.
It demonstrates how arithmetic operations work under the hood in computer architecture and how a number system can be held efficiently.
This is not just a calculator, but a learning tool for understanding how computer interprets number.
Thank you so much for watching our presentation and video. Thanks, Lord.